Okay, so let's get started then. So the agenda for today is the security, container security, I would say, unless you want to widen the discussion. So I'm sorry to say that from Axis side, we couldn't get the security expert to join this time, but hopefully next time.
Yeah. So in addition, so could you please bring back the discussion later, and if you can, could you please get the feedback from the security expert in Axis? Okay.
Yeah, we will. Next time we will join.
Please share the content of this discussion and the discussion in this call.
Yeah, I will.
Okay.
But I have written down some general recommendations from Axis side that we can discuss around. Or does anyone else have a I to kick off the discussion?
So first of all, so I would like to share the progress of our investigation and issues to be solved. Hassan, could you please do the presentation?
Oh, yeah.
We also have something to present after this.
Okay. So
Okay, yeah, then we'll start off with iPro and then Hikvision, and then I'll do my presentation.
okay, so may I start?
Sure, go ahead.
Okay, so here's the stats so that the potential risk that iPro is facing when we're trying to deploy the K3S. Our concerns about is that because our containers that is required some permission to access to the system-based partitions, these partitions. So we are concerned about how we can protect our worker node, because in the real life, maybe the hacker, they can attack to the master node, I assume. So when the master node will occupied by the hacker, so he can deploy some ports that have fully permissions to access to the system, and so from that he can fully control the worker nodes or the worker nodes in the cluster. And currently I only found that have several methods to improve the security in the orchestration system, like a Kubernetes or K3S, for example, using the root list, or you can set the users or permission via the namespace, or using the role-based access controls, or even using the read-only ports that only allow to read instead of changing the root contents. But all of these methods, we have to config, or they can be controlled from the master. So our problem is that how we can avoid the damage to the worker nodes when the master has problems, have occupied from the hacker. So we have we have several ideas. So this is our first approaching. So because we assume that the master node was occupied, so we want to increase the security of the worker node. So it can active protect itself from against the master in the case that lost control. So our target in here is that we will focus on the container runtime. We will improve the security for the container runtime. And in here, so we select the file and the function that we want to add to improve the security is that we want to fully control the volumes mounting function abilities, and also we will disable the privilege port permissions. So it's at least it can prevent the master node deploy the port that have the privilege permissions. So with this target, we have two methods. For the method one, we can, I think we can using some control, the Linux kernel security modules like AppArmor or Linux. But with this approaching, we have to add some additional libraries or dependencies. So, and also we maybe have to change something in our kernels. So we want to avoid it at the first time. The second method is that we focus on the host path mounting functions. Actually, in case 3S, we can using host path by setting up directly using the host path volume source, or we can using via the persistent volume. So we focus on this, and at least with these approachings, we can reduce the security risk that the attacker that he can utilize via the host path functions. So, but after with the previous methods, we found they have some point that we need to consider, and I think with this point here is that in the case that if the hacker they can create a fake port, I mean he deploy a port that have the same or quite similar permissions with the normal port, so maybe he can freely to access to the system base without the acknowledge from the worker node. So with this point that we still don't have the solution for this to prevent this kind of attack. So then that's all from me. So do you have any questions or?
For your reference, so iPro is continuously investigating the security about the container orchestration, and so maybe the final output would be shared at the end of December, maybe.
Can we split this in like two parts? One, more general, which is container runtime, and one with using Kubernetes, because I think there is a more general problem with, or general ways you can secure your container runtime, and specifically using Kubernetes with some specific Kubernetes rules that you can apply. So because the problem, the security problem is general, right? So even if you're not using Kubernetes,
yes.
So I think we because at least from our side, we have not decided to use Kubernetes at all.
Yes. Some remember that from Access you're gonna use the Ansible and continuity.
Yeah, well, Ansible is one way. I mean, so we don't actually have a specific device for orchestration, device requirement for the orchestration. We're just using our already existing APIs. But that's not standardized API, so that's part of our native APIs for managing devices and so on.
Yes.
So Frederick,
Yeah.
Frederick-san, in this meeting, so maybe we we will not discuss the unification about the ecosystem. So far, we only have to provide the users the selection choices. Maybe the ecosystem can be selected by the integrators freely. Therefore, in case of iPro, we would try to use the Kubernetes. In addition, in case of Axis would try to use the Ansible and the container, maybe Docker. And therefore, so far, we would try to share the both of them with the users. It means we should provide the both of the reference implementation. So in this meeting, we would like to discuss the security. Of course, according to the investigation until now, iPro found several issues about the Kubernetes security. However, we will continuously investigate the security about Kubernetes, and so we will solve all issues by the UniMatrix version 1.0. Okay, therefore, in this meeting, we should discuss. We should focus on the security implementation and not about the choice of the ecosystem. Okay.
Yes, I agree. So we should agree on the general security recommendation, the general security measures that we want to promote.
So from iPro side, we explained the security about the Kubernetes caseless. Do you have any comment? Any other comment?
No, not from Axis. Can you share the slides on GitLab or?
Yeah. After this meeting. Yeah. After this meeting, I will upload this document on the GitLab at the meeting.
Okay. Thank you.
Okay. It's Dora-san's turn. Could you please?
Okay. We maybe present something different from your side. And my colleague Leo will present to the presentation. Yeah, share the document. Oh, okay. He will explain.
Okay, so okay. Uh, so in our view, we have a different view with Panasonic's approaching. We think, in our opinion, we ha in our device we want to protect our resource on our device like CPU, memory, I/O device, network, and system core and file and capability. So we prepare a document about how we do that and how we can protect our resources. The first, CPU and memory and I/O device. Limiting the usage of CPU and memory is the basic capability of the container technologies. And CPU cycle in container is controlled through CPU-C group like a CF carry US and CPU dot CF quota US, and we can set maximal memory usage through memory maximal usage in byte. This is in C group system and file system interface. And for I/O device, mount DV in DV directory in container and set permissions through C group device controller. This is an example. And her entry is ended using device control load and remove using device denied. For instance, we can echo this string into the C group interface. So this means allow the CPU C group 1 to read and make node the device, usually known as the DV node. And doing echo A to the file system like this means we'll remove all the device permissions. And about the network, containers should be put in a isolated network namespace in order to manage containers port mapping like Docker. So we can implement our own network model like ETH pair and like this. This container is in the different network namespace with host container and host connected by the ETH pair. So the container didn't so internet couldn't access the container through network if we don't routing the TCP or UDP string to it. And about the syscode, we think syscomp is a computer security facility in Linux kernel. It's allow a percent to make a one-way transition into the security state where it cannot make any system call expect exit signal return read write to a already open file decryptor, and we can enable syscall model through syscall. Here are two examples. Syscall in program. In this program, we include syscall header file, and in this program, we only enable read, write, and single return, and extend group syscall. So if this program want to get PID from the kernel, it will return fail when the program complete and run. You can see this line is never reached. And the last and the second example, syscall in Docker. We can create a configure file like this. Then we save the configure file and try to load the container with the syscall configure above. Then we can run Docker command and load this configure file. So in this container, we deny change models syscall. So the container will return fail when he want to change model of a file in container. And the last about the file and capability. Application in container has its own maintenance space and rootfs, but host may share the file with container. In this case, container will mount some directory in the host will mount some directory in container. We can use DAC or MAC to assessment permission. MAC is a kernel enhancement to confine program to limit a set of resource, and community has some solutions like SE Linux and AppArmor. I think AppArmor is more simple than SE Linux. AppArmor can control capabilities, network access, file permission, and resource limit. Here is an example. The AppArmor in Docker. We can create a AppArmor configure file and disable ping like this. In this file, we enable TCP, enable UDP interface, enable SMP interface, but we deny the RAID module and package because ping is rely on RAID package. So when we finish this configure file, we can load into AppArmor through this command. And once loaded, we can test ping. We can test the no ping profile as follow command. You can see when we try to ping in container, it will return fail because it has a locking privilege of ring socket. That's all. So, any comment?
Yeah, one comment. I mean, AppArmor and SecComp, you have different sections on that, but they're basically doing similar things. So that I mean, SecComp is also an LSM. So it's either, or actually you can use both of them at the same time, I guess. It's a kernel option that you enable. So both of them are syscall prevents syscall. I think AppArmor can also do more things. AppArmor can, for example, filter also access to dbus services.
I know what you mean, but I don't know whether AppArm can control the syscall.
Yes,
So
it can. It can control even. Yeah, it intercepts syscalls and which files you can access and so on.
But if AppArm can do that, it's better. Yeah.
Yeah. So one question is, can we decide on one LSM, or shall we allow different? Shall we allow different vendors to support for different LSM, so that we have to support both AppArmor and SecComp, or can we decide on one? From Axis side, we have looked at mostly at AppArmor and leaning towards that one actually. But we haven't really made a hard decision yet.
From our point of view, we do not need to specify the implementation of the vendor, but we can specify the requirement in UniMatrix. What's your point?
Yeah, but the problem is that, let's say let's say you make an application that is supposed to run on a camera, and then one camera is using SecComp and another camera is using AppArmor. Basically, that application will have to provide AppArmor profile and SecComp, both of these kind of profiles, to be able to run with the container runtime. So but these things can be automatically generated by some tools that can automatically generate this kind of profile. It checks when it's running, what files it opens, and what system calls it makes, and things like that. But yeah, I would prefer if we decide on one of these LSMs instead of having to support multiple.
Here the AppArmor, we just give an example, and yeah. We don't support the Docker in our device.
Yeah, but independently, if you're using an LSM like AppArmor or SecComp, the same principle, this is global in your system. So independently, if they run in a container or if they run natively on the OS, you have to provide when you run an application, even if it's inside the container or it's outside, you have to use this seccomp profile or AppArmor profile when you run, so that you're telling, okay, the system that these things will be accessed by this application, and then it allows to enable it. So it's the same if you run it in a container with Docker, or if you run independently how you run this container. Okay, any other comments?
Frederick-san, so what is the essential elements about the security?
Yeah, I wrote down some things in my presentation. I just wrote down a few bullets that are general recommendations. Maybe I should do that. Okay, can you see my presentation?
Mm-hmm.
Okay,
but
so
letter is very small.
Small? Okay.
Mm-hmm. Okay, I can see.
All right, so I just wrote down some general security recommendations. All of this is not completely defined, I guess. But I think we should scan our containers for known vulnerabilities. This is a service that is provided by some registries already, like Docker Hub. I think also GitLab allows this. I'm not sure if it's allowed in our current. I think we have GitLab Gold. I read somewhere that it's only available in GitLab Ultimate, but maybe we need to check to upgrade our GitLab tier. But basically how it works, I think Docker Hub is using a component from Snyk, which automatically scans for known CVEs. But this is quite complex thing, I guess. Snyk has their own database of CVEs because the public CVE databases are not that trustworthy. So yeah, that's one thing. We should also have a look. I'm not sure how good the GitLab's security scanning is. And another thing is to reduce the attack surface by minimizing the containers. So for example, there's a tool called Docker Slim, which does this. It checks whatever libraries that an application is using, and it's not perfect, I think, but you can do a lot of customization to Docker Slim to get it to include the stuff that you need. I think it can also generate things like AppArmor profiles. So it will check whatever system calls that your application is making and create an AppArmor profile for the application that you can include. The same thing for seccomp, I think. I haven't tried this part myself. I've used Docker Slim to kind of to minimize the runtime containers that we have in the examples, like for Larod and for dbus and so on. Another recommendation is that when you are compiling and linking the applications in your container, that you should use the hardening flags provided by GCC and so on. It's for kind of randomizing some things, so it's harder to attack. If you have if a hacker manages to get root access, for example, it is, if you are using hardening flags in your application, it's much more difficult for an attacker to actually use a known exploit, because things will not always, things will end up in random locations in the heap and so on. So this can be quite easily done by enabling some compiler flags and linker flags. At the cost of some runtime cost. I think you can lose like 5%, 5 to 10%, what I've seen. So depending on which flags you enable. So, and then we come to the LSMs. So I think we should generate profiles for the either for AppArmor or for SecComp or for both of them. So when you do when you write an application, you will include a profile for it, so that the host only allows the access to the exact files that it needs, nothing else. And that will limit the attack surface a lot if the application is compromised. And then number 5 is we should use the user namespace, so that the root, the container root, is not the system root. And then number 6, so each application should have its own user. And then we should grant at installation time, we should have some kind of manifest, application manifest, where the application basically asks for access to certain system groups. And then it gets only access to those groups that it needs. So these are kind of high-level recommendations that map down to some of the things we have discussed so far.
Based on the presentations from Han-san and Dora-san, what is the lacking item?
Lacking
item element. So this is described by you, right?
Yep, this is my.
Yeah. And so Han-san and Dora-san explained their thinking. And so what is the lacking items for the security? Do you have any? Do you find anything else?
Well, one point in Hikvision's presentation was around the CPU utilization and so on. That's it's not really maybe a security. It's not directly a security thing, but it's something that you want to control. Because if one application kind of gets stuck or something, it can occupy the whole CPU. So that's something that we might want to control in an app manifest as well. So I think in the last bullet I have here about a manifest, I think we should maybe discuss that at some point. What do you want to, when you install an application, what things can an application ask for? So one thing is access to certain devices, to certain files, and so on. Another thing is to ask for access to CPU or GPU, so, and of course how much memory and so on. So some things can be controlled by C groups, and some things are controlled by permissions to files and so on. It could also be like in our case, we are using dbus for LAROD access. That one is can also be controlled.
Frederick-san, so what I would like to say is to modify these recommendations based on the presentation of the Dora-san and Han-san. And so the concrete method should be described in the each items 1, 2, 3, 4, 5, 6, 7, maybe 8. I don't know.
But so the question is if how much freedom we should give device.
Yeah.
So
for example,
that's why I'm calling it recommendations, because right now it seems like there's quite a lot of difference between manufacturers how we do different things, and so these are more like recommendations, and you don't have to follow them.
Maybe you misunderstood what I mentioned. So at first, could you please modify the recommendations based on the presentations of Dora-san and Han-san? And in addition, for example, about the number 4, so you defined to use the upper armor. However, so Dora-san suggested upper armor and the second, both of them are okay for the integrators. So I agree with Dora-san. So of course, so we should provide the rights of the selection to the integrators. Therefore, so maybe you should list both of them in the paragraph. And so maybe we should write the essential elements of UniMatrix, and in addition, so the concrete method for each item. Maybe that's all we need to do. How do you feel?
I'm not sure I should do all of that, so I can take care of a few of these. But also, I'm not sure we are. I mean, at this point, I still think this is up in the air to be decided. It's not. These are just these 6 bullets that I wrote down is just some that came from the top of my head. I'm sure there are more things to think about. So at this point, not sure if we can make something really concrete, but yeah, I can maybe update a little bit after looking at your presentations. So also Dora-san, can you please, or Leo-san, can you please also add your presentations to the GitLab?
After this meeting, we will upload it.
Yes, yes. So please, you can create a new. You can create a new merge request on GitLab or send it to the list. Hello.
Yeah. Okay.
Yeah. All right. So I think, yeah, I can update the presentation a little bit about the things we discussed, and also next time I will have also an security expert with me from Axis.
Mm-hmm.
All right. So also anyone else is welcome to. I mean, my presentation is already available in the TV meetings folder. There is a file called container security _access right now. But so you're welcome to add more things and make changes to that file.
Okay.
Okay.
All right. Is there any other comments on this? Otherwise, we'll move on.
Nothing else.
Okay. Yeah, go ahead.
Nothing else from April side about the security and so far.
Also, nothing from our side today. Maybe after next discussion, we can consider to add something more.
All right. So let's discuss the next telco. So.
Frederick-san, so before that, so can I discuss another topic? Okay.
Sure.
So according to April's further investigation about DBAS, and April compared DBAS broker with DBAS daemon. And as a result, so DBAS daemon is greater than DBAS broker is greater than DBAS daemon. And the reason is about high credibility and low memory consumption. Therefore, so we would like to introduce DBAS broker to the UniMatrix. And so, so far, our Railroad need the D-bus and the system D. And so even if D-bus broker is introduced, Railroad cannot work correctly. Is this right?
No, Lara doesn't require system D. That's incorrect. It's using lib system D, but that's only for it doesn't require the system D daemon to be like in in the example I've done. In the example, Python example we have, it doesn't require system D.
Hansan, so is there any problem about D-bus broker introduction?
Not yet. I'm not implement anything related to the D-bus broker.
Not yet.
But in the case if you need it, we can create one.
So at first, we need to confirm the operation of Railroad on our system, right?
Actually, we do some comparisons, but using the Python, some program using Python. And I think to be fair, I think we should compare in C and C++.
Didn't you find any problem about system D? No.
Yes. At this time, I don't find. I'm not fine. I think. I have no issues with Railroad and D-bus.
Okay. Okay. Anyway, so please try to confirm the behavior by using the D-bus broker more, right?
Yes.
Okay.
Yes.
Okay. I'm sorry, Frederick-san. So I misunderstood something.
Okay. The problem with, or should I say, not a problem, but if we should use D-bus broker, we have to write our own, because D-bus broker doesn't access the file system at all. It requires you to give it some file descriptors. So some other program must open these files to the D-bus system socket. So it's probably not a lot of work to do that, but I had a look and I just found it was easier for me to use D-bus daemon for the sample, but it's definitely possible to use D-bus broker. But then someone has to write a small launcher that will open these, open the socket or create it if it's needed, and then pass it on to D-bus broker. I was looking at someone else had written, or someone else had the same question at Stack Overflow or somewhere else, and then, but I didn't find anyone that had actually written that small launcher.
Okay, so Hansan, let's continue to our investigation continues. Yeah. Okay.
Okay, so let's discuss next meeting. I propose to move back to Wednesday because from our security guys not available on Tuesdays. So I suggest to have next telco on the 15th at the same time. So 15th of September at 1300. Is that fine with everyone?
15th, okay.
It's okay from my side.
Okay, then we'll book that. Willie, can you make the booking?
Every 15th of
Yes.
September. At which time? It was 1 o'clock at.
1 o'clock UTC. Yes.
Yeah, I will do that.
Okay, perfect. Then I don't have anything else.
No.
No.
All right. Thanks for joining, and see you next time.
Thank you very much.
Thank you.
Bye-bye.
Thank you.
Bye. See you next time.
Bye-bye.
Bye.